A and B. Take your compass. Let's do B first. Let's do angle B. Put your compass point on angle B for me. Put your compass point on angle B. Make an arc through angle B that intersects both sides of angle B. So nice little arc mark right now. That intersects angle B. Doing angle bisectors, not perpendicular ones, Cal. We're doing angle bisectors here. Okay, go to each point of intersection. Okay, everyone, if you want to look at mine right now, I have one point of intersection and a second point. Put your compass point on one of them. And draw a second arc out in front of the first arc. Draw a second arc out in front of the first. Go to your second point of intersection. Second point of intersection. And draw another arc so the last two intersect each other. Those last two intersect. And grab your straight edge when you have that, and go ahead. I'll wait for everyone to finish up. And if anybody wants to get ahead, go ahead and do the same thing for angle A now. We've got to do it for A and B. So once you get that done, go ahead, see if you can do angle A on your own. Turn your papers if it helps. Turn your papers. Angle B and angle A, I need angle bisectors. Just for neatness sake, I am not going to have you do the third angle and bisect it. If we were to do the third angle, what do you think would happen if you drew in that third angle bisector? They're going to intersect the same spot as the other two. They're going to be concurrent. That word we used yesterday. Concurrent with each other, yes. So go ahead and put a point where at least the two intersected each other. Go ahead and put a nice point where the two intersected each other. And remind me again, what did we just construct here? These are both what? Angle bisectors. So remember, hi, I'm equal, right? Let's not forget that. I know we get all fascinated by this, what this new point is called, but remember there's still angle bisectors. All right, so let's put a new name to this, right? Because if I did draw in the angle bisector for C, it would intersect at that point as well. We have what's called, where the angle bisectors meet in a triangle, in-center. That's called the in-center. Okay, that's where all three angle bisectors meet. A lot of special lines going on. Yesterday, where did the perpendicular bisectors meet? Circumcenter. Well, guess what? Angle bisectors meet at the same point. It's called the in-center. It has a special property. Here's the property, everybody. Go down to my diagram right here, triangle ABC. I will let you know, and please jot down that D is the in-center. D is the in-center of triangle ABC. Okay. Not the circumcenter, the incenter. Incenter. Don't yell anything out, I'll call on somebody. So if D is the incenter, that means AD, DC, and DB are all what? If D is the incenter, that must mean AD, DC, and DB are all what? Incenter. We just did it. That must mean all three of those are called what? 5, 23. Those are all called what? AD, DC, and DB if they all intersect at D, which is the incenter. How do I form the incenter? What did we just construct above? Those are all, does everyone understand how that works? Oh, wait, that's the incenter. It's formed by angle bisectors. Okay, those are all angle bisectors. And now using here's my new theorem about it, my new fact. The incenter, equidistant from the sides of the triangle, all right? The incenter, equidistant from the sides. So now I know that ED, DF, and DG are all congruent to each other. Okay, are all congruent. Equidistant from the sides, and they are formed by the angle bisectors. Bisectors. Questions? So let me just review everything right now. First, yesterday we had circumcenter. Circumcenter, which was the intersection of what? 20? Circumcenter was the intersection of the I have a 20? Yeah. Circumcenter, intersection of the what? Circumcenter. Yesterday's notes is the intersection of the more than bisectors. Perpendicular bisectors. Now we just had the incenter, which is the intersection of the 19, intersection of the angle bisectors. And what did we just learn about the incenter? What's so special about it? 10, what's so special about the incenter? Correct, equidistant from the sides. Questions? They're starting to pile up. They're starting to pile up. We either get a handle on it or we just continue the same pattern. Questions here? Because I got another line to fill out here before we leave today. Incenter, perpendicular bisectors, circumcenter, incenter, angle bisectors, circumcenter, perpendicular bisectors. Anything? Okay, we'll find out at the end. Okay, before I get into the next type of point, I got a new vocabulary term for you, altitude of a triangle. Altitude. You can read the definition, but here's what I'm going to tell you. Altitude starts at a vertice, has to start at a vertice, and it's drawn perpendicular to the opposite side. Let me say that again. It starts at a vertice and has to be drawn perpendicular to the opposite side. Okay? Starts at a vertice, perpendicular. Perpendicular, there's the word you need, to the opposite side. All right, so AD is an altitude. There should be markings you could put on the diagram or something you could tell me now. If it starts at a vertice A and is perpendicular to the opposite side at D, either tell me the markings Or tell me a conclusion you could make if it's perpendicular to the opposite side. Okay, let's roll. Josh, I just heard from you. 6. Perpendicular to the opposite side. Let's just start with markings. What markings could I put on my diagram then if it's perpendicular to the opposite side?
90 degree.
Where? Name the specific angles where I could put 90-degree angles.
ABC.
Yep, or I could put them on ADB. Everyone agree? So here's my conclusion. Angle ADC and angle ADB are right angles. Altitudes are perpendicular to the opposite side. Okay, perpendicular to the opposite side. All right, next question for you before I move on to the construction. In a triangle, specifically this triangle here, how many altitudes do you think you could draw total? And the answer is not infinite. How many altitudes do you think exist in every triangle? Let's think about it. Because it has to start at a vertex and be perpendicular to the opposite side. How many altitudes total do you think there are in every triangle? What do you think, Via?
3.
How many vertices are there?
3.
So I can only draw one altitude from each vertex. So you are correct. There's 3 altitudes in every triangle. 3. What do you think is going to happen to all 3? What's been the common theme here today and yesterday? If I drew all 3 altitudes in, what do you think is going to happen, Cal?
The intersect.
Where? Just at the same point. They're going to intersect at the same point, correct. All right, so if I'm adding to my chart here, perpendicular bisectors, angle bisectors, and now altitudes all intersect at the same point. Grab your compass and straight edge. I just wanted to show you a special type of altitude here. Anybody know what type of triangle this is based on its angles? Not its sides, its angles. Angles. What type of triangle does it look like based on its angles? And here's a hint, that looks a little bit more than 90 degrees, right? That looks a little bit more than 90. So what do I call this then? Go ahead. What do I call it, guys? Obtuse, yep. This is obtuse triangle. And here's what I want to do. Going from point A, everyone. Everyone see point A? Going from point A, I want to draw an altitude to BC. Draw an altitude to BC. What do I know about altitudes again? They have to be what to the opposite side? 20. They have to be what to the opposite side? Altitudes. They got to start at a vertex and be what to the opposite side? Perpendicular. So here's what I need. I need a line coming from A perpendicular to CB. Here's how we do it with your compass. You guys know how to do it already. I just need to review with you. Ready? Put your compass on A. Point A. That's where I start my perpendicular line. But here's the thing. I now need to make an arc, aka looks like a happy face, that intersects BC in 2 spots. Anybody got a problem with that? I do. I can make it hit once. I don't care how wide or how narrow my compass opening is. Anybody going to make it hit twice? Nope. Suggestions? This is what we did in the past too. Suggestions? If I can only have it intersect once. Carter? Extend BC. So grab your straight edge. Let's extend BC out. Now you should be able to hit in 2 spots. Extend it out. Now hit in 2 spots. And then go from each point of intersection that you had, those 2 points we needed, and make 2 more arcs below your first one that intersect each other. So I grab my compass, I'll put it on either point of intersection right now, doesn't matter. I just want to make sure these last two arcs intersect each other. So I don't know, maybe some of you may need to open up your compass a little wider. It's up to you. But I need two arc marks that are going to intersect each other. Line it up with A. Yep, Via.
How do you get like the sorry,
With one.
No, like the bigger one.
This one here?
Yeah, how do you?
I put my compass at A and made sure it intersected twice. That's the very first arc you got to do by extending BC. So I went from point A to make that first arc. And then go ahead, draw your altitude in. You can stop it at BC. You can continue through the arc. It doesn't matter. It's up to you, but we'll keep it right there. And it's perpendicular via.
Does the arc like around? I don't know how to explain it, but like when you make the arc at point A, does it have to be like a specific distance, like from A to B, or?
You need from point A. I just need an arc that intersects CB in two spots. I don't care where, but it's got to intersect in two spots. Okay. Okay, I'm doing this on purpose. When dealing with an obtuse triangle, where is one of the altitudes located? Where did we just locate one? Outside the triangle. Okay, so when you do an obtuse triangle, yes, one of the altitudes will be located on the outside. Okay, as you guys can see here. They do not all have, they will not all be located on the inside. If you have an obtuse triangle, it will be located on the outside. Questions? Okay, I want to go to another type of triangle. Sketch yourself. We're not going to construct this. Sketch yourself a right triangle. Wherever you have room. Wherever you have room. Below that construction, wherever you have room. Sketch yourself a right triangle. Put your right angle symbol in there. Don't make any construction marks, nothing. In your group right now, I'm going to give you about a minute, maybe a minute 30. Do you see any altitudes on your diagram? Talk to your group. Do you see any altitudes on your diagram? Without drawing another thing, are any altitudes on that diagram right now? Are any altitudes on that diagram? Remember what an altitude is. Comes from a vertex perpendicular to the opposite side. Do you see any altitudes in your right triangle? Okay, let's come back now. Did we see any groups find any altitudes when dealing with the right triangle? Did you find one, Zach?
Yeah.
Where? There's two. Two, not one, two, huh? Well, at least where's one of them?
Where they connect.
This side right here is an altitude. Why? Ready? What's this right here? Vertice. Drawing it. What's this? Perpendicular to the opposite side. Isn't that the definition of an altitude? Yeah. And you said there was a second one? The other leg. Yeah. There you go. There's 2 altitudes already on a right triangle. The third one will probably come going here somewhere if I wanted to construct it. Probably coming from here somewhere. All right, there's 2 altitudes. Yes, so in an obtuse triangle, where's one of the altitudes? Outside. For a right triangle, 2 of them are where? Already on, right? Already on the triangle, the 2 legs. Good, good. All right, so going back to my chart here, we said if we ended up, because we don't have the time, if we ended up drawing all 3 altitudes in a single triangle, they would all intersect at a point. They would. All right, and that point is on your notes right there. The point where all the altitudes intersect is called the, anybody want to try to pronounce that? Orthocenter, yep. That is where all 3 altitudes meet. All right, where all 3 altitudes meet. Orthocenter, where all 3 altitudes meet. And I do have at least one piece of good news here. There's nothing special about it. Sorry, there's nothing special about it. Nothing I can tell you special about an orthocenter. But that doesn't mean we're just going to disregard it. Here's the last part of your notes today. You will still be responsible to telling me where it would be located. Okay? Given a triangle, where would it at least be located? So I'm first going to start with a right triangle. If I give you a right triangle, where would the orthocenter be located? Please go back to your right triangle drawing that you had. Didn't we have 2 altitudes already? Where'd they intersect each other? Where do those 2 altitudes intersect each other? Everyone see it? So guess where the, if we drew in the 3rd altitude, guess where it's going to intersect? So what's that point right there? For any right triangle, this point right here is your orthocenter. Yep. So for a right triangle, we can say it's where the legs meet. Okay. For any right triangle, the orthocenter will be where the 2 altitudes, the 2 legs, meet each other. All right, next one. What about an obtuse triangle? Where would the orthocenter be located on an obtuse triangle? And I'm not looking for specifics here, like exactly where, but where's at least one of the altitudes? So where's the orthocenter have to be? It's going to, does that make sense? If one of the altitudes is outside, somewhere on that altitude is the orthocenter. It's got to be outside. Yep. So go ahead, outside. That's I'll be right there in a second. What's the 3rd triangle we got to talk about? Acute. Yep. John Perlin. Yep, you got it. Yep, go back. Romeo, I got to go to the main office. Okay, take all your stuff. And then the last one is an acute triangle. That's similar to the original diagram we started with today when I introduced altitude. What do you think? Where do you think all the altitudes would be in a acute triangle? Inside, so where's the orthocenter? Inside as well. Yep. So all you're responsible for is where they're located. Okay, that's all I'm going to have you be responsible for. All right, you guys know where I am. I will sit down with you and get all this organized because we have one more special point to go tomorrow. All right, come on in. We'll get it all organized, whether that be index cards or something else. We'll get them all organized. Hold on. Take your packets back out. We still got 2 more minutes. Front of your packet, because I wasn't here yesterday. Front of your packet. Tuesday, first quiz. And that is the day before break, so if anybody has travel plans, might be a good idea to get that thing done before you leave. All right, because as the break goes on, the more stuff we forget. Okay, so Tuesday, what is that, 22nd? 3rd, thank you, 23rd. Yep, Tuesday the 23rd. That's going to be the first quiz.